Commutative property. Commutative property applies only to multiplication and addition. Commutative property of multiplication means even if we change the order of numbers that we are multiplying, will not change the product. So, changing the order of the numbers we are multiplying does not change the product. For example, 4 times 3 is equal to 3 times 4. 4 times 3 is equal to 3 times 4. 4 times 3 is 12 and 3 times 4 is also 12. So both are the same. Okay, we will see an example for that. I have drawn arrays for 3 rows of 4 and 4 rows of 3. In 3 rows of 4, so we have 3 rows of 4. So 1 row of 4, 2 rows of 4 and 3 rows of 4. And each row has 4. That means the size of each group is 4. Right? So, in the next array, if you see, there are 4 rows of 3. Let me check. So, this is the first row of 3, second row of 3, third row of 3, and fourth row of 3. There are 4 rows of 3. And then the size of each group is 3. So, that's the size of each group. That is 3. If you see the total, 3 times 4 is also 12. And 4 times 3 is also 12. So, even if you change the order of the factors, the answer is going to be the same. That means the product is going to be the same. So, this is called the commutative property of multiplication. Now, I'll show you an example of the commutative property of addition. Similar to multiplication, even in addition, if we change the order of the addends, the answer is not going to change. Let's see. In the first green box, I've written 5 plus 3, and in the second black box, I have shown 3 plus 5. If you see, when I add 5 dots and 3 dots, the answer is 8. And in the black box, when I add 3 dots and 5 dots, the answer is the same 8. So this is an example of commutative property of addition. The question here is, draw an array that shows 5 rows of 2. So here is an array that shows 5 rows of 2. So first row of 2, second row of 2, third row of 2, fourth row of 2, and fifth row of 2. And each row contains 2. That means the size of each group is 2. What we have to do now is write a multiplication sentence where the first factor represents the number of rows. We have to write a multiplication equation, and the multiplication equation will have 2 factors. And the first factor has to represent the number of rows. Or you can call it as number of groups. Let us add the number of groups. 1, 2, 3, 4, 5. So there are 5 groups. For 5 groups, let me write 5 as the first factor. And the second factor will be the size of each group. How did I get 2? The size of each group is 2. So this is 1 and 2. Size of each group is 2. So 5 times 2 equals, that means 5 times 2 is 5 plus 5, which is 10. If you see in this array, the total will be 10. Let's move on to the next question. Draw an array that shows 2 rows of 5. Write a multiplication sentence where the first factor represents the number of rows. So here is an array that shows 2 rows of 5. So this is the first row of 5 and this is the second row of 5. So what we have to do now is we have to write a multiplication sentence, and the first factor should represent the number of rows or number of groups. Okay, so let us count. This is the first row of the array, and this is the second row or the group of an array. So there are two groups in this array. So the multiplication equation will be, so 2 times the size of each group is 5, right? Okay, so 2 times 5 equals 10. How did I get 10? 2 times 5 means 5 plus 5 equals 10. If you see in this array, the total will be 10. The question here is, write a multiplication equation. You know that a multiplication equation will have an equal sign in it. Okay, the 7 twos. How to write 7 twos? 7 twos means 7 times 2. Since it's an equation, we should write an equal sign in it. So 7 times 2 means 7 plus 7, which is 14. Okay, the next question is, 2 sevens should be written as a multiplication equation. The 2 sevens can be written as 2 times 7. 2 times 7. 2 times 7 is also 14. Let me draw an array that represents this equation. Okay, so this is an array that represents 7 times 2 equals 14, and this is the array that represents 2 times 7 equals 14. The 7, 2, 2, 7 are called the factors. No matter in which order we write the factors, the product is always going to be 14. So this is called the commutative property of multiplication. Let us do a problem. Find the unknown factor to make each equation true. 2 times 8 equals 8 times dash, and dash times 2 equals 2 times 4. So here I'm changing the order of the factors. 2 times 8 into 8 times 2. So this is a commutative property. So the unknown factor here will be 2. 2 times 8 will be equal to 8 times 2. And in this, dash times 2 equals 2 times 4. I'm changing the order of 2 times 4 into 4 times 2. So the unknown factor here is going to be 4. So 4 2 times 8 is 16 and 8 times 2 is also 16. Similarly, 4 times 2 is 8 and 2 times 4 is also 8. So 16 is equal to 16 and 8 is equal to 8, and that proves the commutative property of multiplication.